Hey ChemStars, this is Mrs. Vandewall bringing you another ChemStar video. We are now in chapter 16, which is called Reaction Energy. Sometimes this is known as thermodynamics, or in this case, thermochemistry as well. So if you just look at the title of the chapter, it says Reaction Energy. So this is how much energy is associated with chemical reactions, okay? So let's begin with section 16.1.1, and we're going to be talking about temperature and heat. Hopefully these are two terms that you are somewhat familiar with, and I know we've already talked about temperature when we were in the gas law unit. We talked about it being in Celsius and in Kelvin, so that should be helpful. So what about heat? What is heat? Well, we're going to find that out. So I can define temperature and state the units in which it's measured. I already told you. I can define heat, which is different than temperature, and state the units in which it is measured. So we do have some vocabulary here. All right, so let's talk about temperature. It is a measure of the average kinetic. And what does kinetic mean to you? It means motion. So it is a measure of the average motion energy of the motion of the particles in a sample of matter. Okay, so we talked about gases having motion. All right, does liquid have motions? Yes, it does. All right, the liquid molecules are moving around, right? What about solids? Do they have motion? And the answer there again is yes. All right, there's a vibrational component to a solid. Okay, so we said in the gas law, we said temperature was related to speed. All right, remember that. So the kinetic again infers motion, and in chemistry, solids and liquids and gases all record a temperature. If they don't, it's an absolute temperature. And if you recall, we have never ever yet, we've come close, been able to actually achieve absolute zero. So every particle that we know of, solid, liquid, or gas, has some motion related to it. Okay, so that's temperature. Again, it is a measure of the average motion of a particle. Okay, so what is heat then? Well, it is the amount of energy transferred, okay? Transferred. It can be measured in joules, calories, or what I call capital calories, okay? So think about that for a second, okay? I know you've heard of calories before. So what is that? Well, a joule is like a calorie. The only difference is a factor of 4.18. So a joule is an SI unit of heat and other forms of energy. Joule is defined as a Newton times a meter, or if you want to get specific, a kilogram times meter squared over second squared. And so let's talk about this. Let's talk about this heat. What do you think of when you hear calories? All right, and how can this relate to the topic? Well, what do you think when you hear the word calories? I'm sure everyone came up with something very similar, and for me, it's food. All right, I think of food. All right, so then what? How is it related to this topic? Well, how much energy does it take to burn off what you just ate? All right, so if you're trying to lose weight, are you counting calories? Yes. All right, so how much energy will it take to burn off what I just ate? In other words, this is for me, how long do I have to walk to work it off? Guys, I don't run, all right? But some of you do, all right? So if you run, if you're on the cross-country team or something, you're running all the time, all right, you're burning a lot of energy. I bet you're not too worried about how much food you are consuming because you're going to burn it all off, all right? So notice I put the word burn in capitals, all right? Isn't that kind of implying energy? All right, burning and energy, yes. So a calorie is a unit of heat, okay? And a joule is a unit of heat. And again, I've already said this. The only difference between a joule and a calorie is the number 4.18. Okay, so it's really the same idea. Now, let's talk about this idea of energy transfer. Is the energy transferred because of differences in their what? In their temperatures. So this heat always flows transferred from hot to cold. And hopefully that makes sense to you. Hopefully that makes sense. So let's take a look at these pictures. All right, in the first picture, a sample of brass right here, all right, is heated by a Bunsen burner. And folks, Bunsen burners get really hot. So if you let this piece of brass get to the same temperature as the Bunsen burner, it's like 700 degrees Celsius. It's really, really hot, okay? It is super duper hot. And here's my beaker of water, and my beaker of water is at 21 point, looks like, I don't know, 2 or 7 or something degrees Celsius, all right? It looks like a 2 to me. Okay, so it's about room temperature, a little bit colder than room temperature, right? So this is flaming hot, and this is room temperature-ish, okay? So what happens in the second picture? The brass that's really, really hot was placed into the container of water. And what did you notice happen? The temperature went up, all right? So let's check this out. All right, so what happened to the temperature of the water? Well, that's an easy question, don't you think? It went up from, again, I'm guessing it says 21.2 to 35.4 degrees Celsius. You can see the little symbols in there, right? So the question now is, why? All right, why did it go up? Well, duh, Mrs. Vanderwilly, you put that hot piece of brass into the water, all right? So what can we say now? The heat was transferred from the really hot brass to the colder water. All right, so the heat was transferred from hot brass to cold water. So when will the temperature of the water stop going up? I don't know if this is the final temperature. I can't tell you that, all right, from the picture. It might be. All right, so when will this number go up or stop going up? All right, well, here's something. When the water has the same temperature as of the brass, not the 700 degrees, whatever. All right, the brass's temperature is going to go down. Why will that brass temperature go down? Because it lost heat. All right, so if you lose heat, the temperature goes down. If you gain heat, the temperature goes up. All right, so when will it stop going up? When the brass stops going down. Hopefully that makes some sense to you. All right, let's go on to the next page. Actually, let's not go on to the last page. We are at the end of section 16.1.1. So don't wait to be great, and we'll see you next time. Bye-bye.